Hey folks, welcome to the video about systems of equations and solving them with matrices. I thought we'd better start with talking about what a system of equations is to begin with. So a system of equations is when we have two or more equations at once. And we try and solve it. Okay, so to solve it, we find the intersection point. Or in the case of more than two equations, multiple intersection points. So the solution is called the intersection point. That would be the solution. So for example, if we just mark off, some points on this grid, maybe I have the equation y equals 1/2 x plus 1, so I'm starting at 1, and I'm going to go up 1 and over 2, and up 1 and over 2. It's going to be roughly approximate, but let me grab a line, draw that line in there. And then let's say we have the equation y equals negative 2x plus 6. So 1, 2, 3, 4, 5, 6. I'm starting up here at 6. And I'm going down 2 and over 1. And down 2 and over 1. And down 2 and over 1. And again, I'll draw another line. And so hopefully we're seeing a nice intersection point here of 2 over 2 and up 2. So that there is my solution to the system that has these two equations in it. A couple more things to write now. The equations can be any type of function. They could be linear. I could have done a parabola here and shown where the parabola intersects. Sometimes you get two intersection points there. Okay, but we will be working with linear equations, linear functions, for the purpose of this unit. And I wanted to remind you of the standard form of a linear function. Hopefully this is a good review. It's in the form ax plus by is equal to c. So the form I just gave you up here was this, the y equals mx plus b form that we're probably most familiar with. But we're going to be working with a form ax plus by equals c. And so that's another way to show a line. All right, let's look at an example. So we're going to use matrices, because we've just learned a lot about matrices, to solve this system of equations. So we have two equations here. They're both in standard form. Oops. Both in standard form. And what we're going to do is we're going to make a matrix out of, we're going to make multiple matrices. We're going to make a matrix out of the numbers that are in these two equations. Okay? So we're going to, actually we call it a matrix equation. So we're going to take the coefficients. The coefficients are the numbers that are right in front of the variable. We're going to take those four coefficients and put them down into a matrix. So we're going to take 3, 2, 5, and 3 and put it into a matrix. We'll just take the x and y because we know we're using x and y. So we put those into just a little matrix by themselves. And then we take the two numbers on the end and put those into a matrix by themselves. So we're looking at like this 2 by 2 matrix, the row times the column, so the 3 matches up with the x and the 2 matches up with the y, and then the bottom part, the 5 matches up with the x and the 3 matches up with the y, right? Remember, multiply matrices, the row times the column. So this is called the matrix equation. In terms of showing your work, this is a major step in showing your work. Okay, so I'm going to want to see how you went from two equations in standard form to a matrix equation. And then we're going to use the graphing calculator to solve the equation. So if you look at your next page, it shows you matrix A was the 2 by 2 matrix, and so that was the 3, 2, 5, 3 part. Matrix B is the 2 by 1 matrix. That was the 7 and the 11. Now, when you solve an equation, you do the inverse operation. Same thing that's going to happen when we solve the matrix equation. We're going to do the inverse operation. So we had the matrix 3, 2, 5, 3. We had X and Y, and we have 7 and 11, and we've labeled this matrix A, and we've put it in the calculator as matrix A, and this one matrix B, and we've put it in the calculator as matrix B. So what we can do is this operation right here is going to be solving the matrix equation by using the inverse. Okay, so we use inverse operations to solve the equation. So by putting in A first and then doing it to the -1 power, and I can show you that on your calculator, and then multiplying by B, I'm going to solve the equation so it looks like my X, Y coordinate point will be 1, 2 as the intersection point. Let me show you what that looks like on my calculator. I've already put in, so if I do second matrix over, here's matrix A, my 3, 2, 5, 3. Or second matrix over, here's matrix B, my 7 and my 11. So if I go back to my blank screen and pull up matrix A, there it is, and I want to do it to the -1 power, which is the button right here on the left-hand side. That way I have the inverse of A times, pull up matrix B, there's my B, go ahead and hit enter, there's my intersection point 1 and 2. Pretty sweet. Let's look at another example. If you look at, excuse me, 5x plus 3y, 25, these are both in standard form, 2x minus 4y equals -18. First step is to make that matrix equation, so I'm going to take the 4 coefficients, 5 and 3, 2, be very careful to take the negative with it if there's a subtraction sign there. So this is actually a -4. X and Y, and 25, and -18. So there's my matrix equation. I plug this in for A in my calculator, this one in for B. I'm going to solve. So in my calculator, I'm going to do the A, matrix A to the -1 power, times matrix B, and let's plug that in the calculator and see what you get. So back to the calculator, you're going to have to edit, so second matrix, over. This is still a 2 by 2 matrix, but now I have 5, 3, 2, -4, and I'm going to go edit matrix B, and that is still a 2 by 1 matrix, 25 and -18, and I go back to my blank screen, I'm going to clear that, I'm going to do matrix A to the -1 power times matrix B, and I get some decimals, and that's fine, but what you want to do is write down on your paper, maybe round it to 2 or 3 decimal places. I might round this to 1.77 and 5.38. So back to the systems page. My answer is 1.77 and 5.38. Or interpret that as an XY coordinate point, 1.77, 5.38. Moving along, next problem. Okay, hopefully you're well ahead of me already making your matrix equation. 3, 2, 9, and 6, and X and Y, and 6 and negative 6. Sorry, my matrices are getting sloppier. So here's my matrix equation. I'm going to plug this in for A, and this one in for B. So again, I'm going to jump to the calculator, clear that, go into matrix. Matrix A, still a 2 by 2. It's 3, 2, 9, 6. Second matrix, over, down 1. Matrix B is still 2 by 1, and this is going to be 6 and negative 6. If you're putting in negative, you have to use the negative sign, not the subtraction sign. That's going to make a difference for you guys. Quit. Pull up matrix A to negative 1 power times matrix B, and it says, error, singular mat. And what that is, I intended for this to happen, just so you know. It means singular matrix. So this gets us an error message. Singular matrix is not the answer, okay? But it is a common result sometimes when you have two equations. There's a couple special circumstances that can happen. If you look at these two equations, hopefully you're saying to yourself, these numbers are sort of fairly similar. In fact, if I'll just use a different color, if I multiply this top equation by 3, then I get 9x plus 6y is equal to 18. Here's the other equation, which was 9x plus 6y is equal to negative 6. This is very similar here. And in fact, if you graphed these two equations, you would have two lines that are exactly parallel. Do parallel lines ever have an intersection point? Hopefully you're saying no. So it's because they never intersect, we're never going to get an xy value. So what we would say is the correct answer would say that there is no solution. L-U-T-I. No solution to this system of equations. Okay? I think you have a gold sheet already, so you probably want to add one of these examples to your gold sheet, and we'll be practicing more in class.